Now pulsars can be done in two ways. One is called by transmission method, where the light passes through the finger tip and is received on the other side. The two wavelengths used, red and infrared, and the detector is common. You have only red or infrared at a time, not both. Either it's the red or infrared, and that's how you how detect. So this is what the packet which has got a source and a detector. Now if I put it on, you will not see the, you will see only the red light inside this. This will start. You will not see infrared because that's not visible. But infrared is also the arrow side by side in the red and a common red. So when you put it, you are supposed to put them in this direction. It will show on the diagram there. On which you can. The nail has to be on the top. So red and infrared wavelengths will go through this. A common detector is there, large area detector, which will detect it. There is a flat response for both the red and infrared. So you don't have to compensate for the intensity variation for the given drive. Okay. There are so many issues involved. Like if you have a diode and infrared diode, how are you going to excite them? There are two methods. One is known as constant voltage excitation method. Other is known as constant current excitation method. Let's explain. I'm starting from the source because that's the way it should begin. And the chopper right now. Okay. Now suppose you say that the arrows are arranged like this. Okay, this is one way of composition. I'm talking about the source only. This is your red, this is the iron. Okay, and then the common detector. This is what it is. You have to put your finger over here. Now, either you must have red on or infrared. You can have both. You can have both of them off. That is possible. You can have both of them off. This is acceptable. This is acceptable. But both of them on is not possible. You cannot put both together at the same time. Either you must have red or infrared or both of them off. Now, when both of them are off, the detector sees the ambient light. Why is it ambient light? Because if you open this and put your finger inside, there is no way you can avoid the ambient from going to the detector. However, you try. Okay, you can put it inside a envelope and then ensure that ambient can be minimized. We can't even do it. So this detector has one output which is called an ambient output. Whenever the red is put on, it should not be on the detector. It should never be a case where, so either it's ambient, this when it's off, you are looking at the ambient light. When the red is on, you are looking at the output of the detector, which is for red element, and this is for the IR. So for IR is now detector output. So detector is one. A new output for ambient, for red or infrared. So how do you expect? Suppose you are on a timing diagram. You say my red is on here. Fine. Then I have an infrared which is on here. And then I wait for some time. And nothing is good there. Again I start the process again. This will repeat. Red, IR, this is ambient portion. Here is ambient. And again red. So this is the cycle you have to use. Excite red, turn it off, go to IR, turn it off, go to ambient. So detector is going to see three components of the intensity. One coming from the red light. But remember, it is passing through the finger. So you are not seeing directly the light. You are seeing the light is transmitted to the finger. This is clear. You can say now, in this package, there could be other choice that instead of being like this, you have put the diodes in the opposite direction. In this way. What is the advantage of this? Here, you will obviously find that you will have to put both of them on or both of them off. So this is not acceptable. So what do you suggest? That I have a switch here. One switch A and a switch. If this is a switch which is open, this is a switch which is going to be closed. Will it accept it? No. I want a switch. Normally both of them are open. So, okay, I'll put it this way. And B. If A is closed, you get red light. If B is closed, you get infrared light. If both are open, you get ambient light. This is simple. And the extension used here is voltage excitation. That means I'm going to put some resistance in series with this. Okay, R. I'll call it forward and I'm going to apply some voltage EF. So I can find out whether the current went through the red diode or the current through the infrared diode. But you have to remember that VF for red is not same as VF for infrared. They are different. So obviously for a given RF, you're not going to have the same current going to either the diode. The current with the diode is going to be VF minus the it's VF minus, sorry, I can call it V source. V source minus VF divided by the RF is the current. But since this VF itself is not going to be the same for both the devices, you will end up having a dollar line and the same voltage side is going to have a different intensity of the two sources that you use. That is also not acceptable. So what we do is, instead, we use what is known as the current drive. Now current drive can be explained like this. It's called Holland current pump, LCP. Holland current pump, Holland is the person who invented this current pump, it's an advanced scientific. Now that has a property that the current can be in this direction or it can go in the opposite direction. If it is going down towards the load, it's called I source. If it is going in the opposite direction, it's called I sim. Okay? Now, if you source the current in this configuration and this is R, this is IR, when you're sourcing current, the sourcing current will go in this direction and the same current will go in opposite direction. So, by changing the direction of the Holland current pump, you can make it a red on or an infrared on. But you can also control the magnitude of the current. You independently can control what is the value of my IR and what is the value of my I infrared IR. So the current going to the infrared diode and have a different magnitude, and current going to the red diode have a different magnitude. The reason is that you want to source to have the same intensities, which necessarily means that you can have different currents. But the same current infrared and red are not going to be the same intensity. If you have a flash detector, if you want to look at the wavelengths, some intensity falling on it, then obviously you have to have red current values and control this IR separately and this infrared separately. So we have a device, a circuit known as digitally programmable Holland current pump, DADP-SCP. It's a short form for digitally programmable Holland current pump. What does it mean? If this is a black box, it has got 8 inputs. So magnitude of this current can be controlled in 256 steps by the sourcing and same value is sinking. So you can digitally control the current which is the latest that is now coming into Oximeter. That you want to current on drive. So what is source? Now there is a lot of confusion. This package is called a transducer. The correct terminology for this is not a fingertip sensor, it is a fingertip transducer. The reason is transducer is the generic term. It consists of sensor and sensor is same as detector and actuators or effectors. If a device basically the definition of transducer is that it converts one form of the energy into other, like electrical energy into optical energy or optical energy into electrical energy. This is the way the transducers are defined. Now, infrared diode and the red diode are known as actuators or effectors. Because they are going to produce a light output proportional to the input which is current or voltage. But whereas the detector, which is a photo detector, is the sensor. So this is a lot of confusion always people have, but which is the sensor? Whether the diode is the sensor or the detector is the sensor. So diode is the actuator. The photo detector is the sensor which is sitting at the bottom of the finger. On the top, there are actuators or effectors. That's the kind of terminology we should use when we are discussing the diode. Fine, so as I said, the state of art, we started with what is called the voltage drive. When we designed this product, we never had this Holland current pump at this voltage. So we started with the voltage drive, and we had these two switches implemented in the electronics, where we used to either operate A or B or both off, but both on is not possible. So what is the best way to do it? It's a complementary drive inversion, but that is also not. You can see that logic I leave to you to decide what sort of drive should be used here. Okay. So coming back to the sensor part, this is what the ready-made sensors are available. I think the pricing of pulse oximeter, if you go to a clinic, in a hospital, when the nurse comes to you, she will come with a sensor like this, and on the top of the sensor, you will have two displays. One of them will give you oxygen saturation level, other will give you heart rate, pulse rate, not the heart rate. The pulse rate and heart rate should be normally same, but if you have a blood pressure up to here, the pulse rate can go to 0. Heart rate is still calm. And if the pulse rate goes to 0, you can get gangrene. Remember that. So never put that blood pressure up for a long period of time. You can literally kill your hand. You can put it for overnight. So this happens many clinics. They have this problem that they have the patients are suffering from gangrene no blood flow. Okay. Now, pulse oximeter is a very good application. We can also use as a lie detector. Okay. If there is a person committing a crime, faces the situation again same, or is projecting the slides relevant to the crime which has committed, and his heart rate would be, if the heart rate prevalent, his heart rate will not change. It won't change the expressions also, but his pulse rate will be equal. His pulse rate will immediately change if he sees the slide or scene of crime. And this is used as a lie detector also in defensive of psychological research in value. Okay. What happens is the pulse rate gets affected the moment he sees association with the crime. Anyway, that's a debatable issue. You can say lie detectors themselves are liars. Let's not worry about that part. Okay, we go next one. I think with this all introduction, I'll start with. I'm not going to design.